Okay, so we talked about this last time. So if you have 2 points, you're taking a slope between them. As the second point gets closer and closer to your first, the slope gets more and more accurate, more and more closer to the tangent line. So the tangent line touches a point once. It's a tangent. Instead of having the secant touching 2 points of the graph, the tangent only touches 1 point of it. So if I would plug in, if I had 2 points, x comma f of x, so that's my first point, and then my second is x plus h comma f of x plus h. So here this h just means a certain distance away. So let's say I wanted to find at 1 and at 5. All right, so if my x is 1, I would be 4 units away. My h would be a plus 4 because I'm plus 4 over. And then when I say f of x plus h, that just means the y value, the function's value at the second x value. So if I plug in x1 and y1, x2, y2, notice that into the slope equation, I see I have the second y minus the first, second x minus the first. The x's cancel out on the bottom, and I'm left with this wonderful equation that is the instantaneous rate of change. So the difference between instantaneous rate of change and average rate of change. Let's discuss what they mean. When you're driving a car and you look at your speedometer, that is your instantaneous, because at that one instant, that's your speed. Instantaneous is at the 1 point versus average. If I'm driving to Vegas, it's like 260 miles. So if I'm going, if it takes me let's say 240 miles. If I'm going it takes me 4 hours to get there, I'm going 60 miles an hour. But guarantee, when I'm driving through LA, I am not going 60, I'm going 10 if I'm lucky, because stupid Coachella traffic. So, it's a real story. Spring break sucked. It took 8.5 hours to get to Vegas. 8.5. Anyway, so if I was looking at my average, I look at the total time and the distance. Okay, here's my average. But heck no, at one point, might be going 80, 90, whatever. At that one instant, I might be going a different speed, but the average is over the whole time. So here, this is instantaneous, so this is our tangent. This is how I find the slope of the tangent. All right, so here's example 1. Find the slope of the line tangent to the graph at each function at the given point. So I want the slope of the tangent line. And my function is y equals x squared. And I'm wanting at 2, 4. So this is my x, and this is my f of x. Saying f of x is the same thing as saying y. All right, so here's my x, here's my f of x. Okay, so I'm going to start off with the formula. So we said the formula was m equals the limit as h approaches 0 of f of x plus h. So that's y2, that's the second y value, minus our y1, our first y value, well, that was just f of x, over, normally we do the second x value minus the first, right, the change, but we already figured out from our derivation before that literally it's just all over h. Here, once again, what does this h mean? It's just the distance between the two x values. So h is literally how many units away they are. So if I'm looking at x equals 1 and x equals 2, what is my h value? If I'm looking at x equals 1 and x equals 2, 1, because that's the distance between them. And what I'm doing is I'm taking the limit as h goes to 0, meaning as h gets closer and closer to my first value, as the distance between my x value shrinks, what's happening to my slope? That's what this means. And I'll probably say that 3 more times during this class, just so you understand what does this mean. Okay, as I stated, this what? We should memorize that. C. Yes. All right, this is the formula. Yeah, because you're going to use it. This is one of, I hate to put a number on it, but it's one of the 4 important parts of calculus. Yeah, it's all about derivatives. Okay, cool. You writing this down? Okay, cool. Just make sure. I'm just trying to help you guys keep engaged. All right, so here, what's my x value? What's my x value? So y equals x squared at 2, 4. So 2 is my x, so I'm going to literally plug in. Let's substitute in 2 in for x. So I have the limit as h approaches 0 of, let's see, f of 2 plus h. Oh my gosh, gotta write it nicer. F of 2 plus h minus f of 2 all over h. Okay, so now when I say like f of 2, that means I'm plugging 2 into my function. When I say f of 2 plus h, I'm going to take 2 plus h, plug it into my function. What is my function here I'm going to plug into? I'm subbing everything. Y equals x squared. That's literally f of x equals x squared. That's like what it means. F of x and y mean the same thing. It's like, I don't know, saying tree and Elon. Aha, because it's Hebrew for tree. Means the same thing. Okay, cool. So I'm going to plug in these into the function. So I have the limit as h approaches 0 of 2 plus h squared minus 2 squared all over h. So I plugged this in this middle, the x value in for x. So I plugged 2 plus h in for x. I plugged 2 in for x. So now that I have that, I can actually go through and FOIL. So I'm going to be multiplying and simplifying that. It's not the same color. Whatever. So I'm going to go through simplify. Yeah. Multiply and simplify. Taking limit as h approaches 0. So 2 plus h, FOIL it out. So it's going to be 4 plus 4h plus h squared. Minus 2 squared is 4 all over h. You'll notice that 4 minus 4, those go away, yeah. So I'm left with 4h plus h squared all over h as h goes to 0. But there's an h in every single term. Yep. So as h goes to 0 of 4 plus h. So you plug that puppy in for h, and I have 4 plus 0. Direct substitution. Because you could try to draw the line and figure out what the slope would be, because that was our whole goal, was like find out. Only I could draw nicely. We were looking for the slope. So here, that's what the slope of the tangent line would be, is 4. Hey, algebra.
Also be 0?
No.
Like just the
at the slope, because look, the slope is like this. 0 would mean the slope is flat. Here, the slope is going up, and it's positive.
This way, if the line
infinite.
If the line was this way, it wouldn't have it. It would only have one solution.
If it was going this way, the slope is undefined because it's straight up and down.
Oh, and you can't have that.
And then that would mean we'd find it would be like infinity when we plug it in. Okay, so it's a little crazy, but you know, it's fine. We can do part B and like figure out what's going on. Let's keep going. What do you mean? F here is like, f of 2 means the y value at 2. F is like the function at 2. So, cool, it's function notation. Let's go to the next page. We need more time to write?
Can you not just plug in 0 at the beginning?
No, because you would get 0 on bottom. You don't want to be dividing by 0. Use direct substitution. Cool. Okay, keep going. Part B. So here's my function, y equals x squared plus 4. So I'm at negative 2 comma a. So this is my x comma f of x. So if I would draw the tangent line here, oh my god, come on. Tangent line. Look, I touch it at exactly 1 point. Is the slope? Want to know what the slope is? Is it positive or negative? Negative, because it's going down. Okay, it's going down. So at the end, we should be having a negative number for my tangent, for the slope of my tangent line. So I'm going to start off with the formula. M equals the limit as h goes to 0 of f of x plus h minus f of x all over h. That's the formula. Now I want to plug in at what x value am I evaluating this? Negative 2. So I'm going to plug in negative 2 everywhere I see x. So I'm trying to systematically approach this, that way you can follow along with your homework. So f of negative 2 plus h minus f of negative 2 all over h. Huh? So h is standing for the distance between the two x values. It's like your unit away. Are you asking why we use the letter h and not just a different letter?
No. How do you know 0?
H units away. The most accurate approximation. H units away. So that's why. All right.
Is it gonna approach 0 every time?
Yeah, as h is approaching 0, meaning as if I'm taking the slope between 2 points, as my points are getting closer and closer together, because the distance, what's happening to the distance between them? It's getting smaller. It's approaching 0. So h is the distance between them, and if the distance is approaching 0, oops, hey, joint circus. As the distance between them is getting closer and closer, as they get closer, the distance between them goes to 0, and then you're getting closer to a tangent line instead of having a secant tangent. Okay, so now that I have that, I know f of x, aka your y value. Those mean the same thing. I know y is equal to x squared plus 4. So I'm going to rewrite this. And everywhere where I see an x, I'm going to be plugging in negative 2 plus h. So that's for the first part. So I'm going to have negative 2 plus h squared plus 4 minus negative 2 squared plus 4 all over h. So you'll see this whole thing right here. It's just, what was my original x value? Oh yes, it was negative 2 plus h. Okay, so my goal right now, have you see, I'm taking like, oh, what x value am I evaluating at? Oh, negative 2 plus some distance h. Plug that in where you see x. So I get, now we're going to go through, simplify, multiply this out, meaning if I have negative 2 plus h squared, take that guy, FOIL it out.
I don't understand this step right here.
What we're about to do?
I understand that y is x squared plus 4, but how do you plug that
So
in?
if I plug in a value of negative 2 plus h, and for x, you get negative 2 plus h squared plus 4.
Oh, because
that's what we're doing.
Negative 2 plus h is
so that was my goal with the
x.
blue. My blue is to show you I'm plugging that in for x.
Okay.
That was what I was doing.
Okay.
Okay, so if I'm going to FOIL this out, just to make sure we're all on the same page. Negative 2 plus h times negative 2 plus h. 4 minus 2h plus h squared gives you 4 minus 4h plus h squared. Four minus 4h plus h squared. So that was this segment right here. But then don't forget to do your plus 4 minus, let's see, negative 2 squared is 4. 4 plus 4 is 8. All over h. So I'm trying to show you every step. Simplify it one more time. 8 minus 4h plus h squared minus 8 all over h. Oh my god, those 8's go away. So something I could do is an intermediate step. So my 8's went away, right? So those go away. Then I have negative 4h plus h squared all over h. So the first time, I just divided every single term by h. This time, I was showing you another way to approach it, right? I pulled out an h. I factor out an h. There was a common factor, right? So negative 4h plus h squared is the same thing as h times negative 4 plus h. It's another way of seeing how it cancels. Last thing is to check, is this a reasonable answer? Is this a reasonable answer? Yes.
Sounds pretty reasonable.
Because it was supposed to be negative. It's supposed to be negative. It's negative. Okay, cool. We didn't know what number it should be. We just knew it should be negative. It's negative. Okay, at least we know we're like halfway there. If we would have got a positive number, you knew you made a mistake. So any little time there's like a super fast semi-check to make sure you're on the right track, I would totally do it. So part of my job is to teach you how to check that. Cool. All right. So we've been I've been purposely like zooming in on the algebra and not really referring to the graph because the next example is to find an equation of the slope for a function and we don't even have the graph. More or less, it's exactly what we've been doing. I just didn't give you a picture. That's it. And I'm not giving you a point to evaluate on. I'm having you evaluate a function. So cool. Do we need more time to try this? All right, let's keep going. Okay, so we want the equation for the slope, meaning I could plug in a certain x value and I could know the slope at any single point. That way I wouldn't have to be like, okay, at this point, what is it? And go through the whole mess. This point, we'll go through the whole mess. No. If I have an equation for the slope, heck yeah, I can pick any x value and I'll have the exact slope. So I have, this is going to be my function. Also recommend writing small. I'm sorry, I should have given you more space, but I didn't. I will space it out next time. Okay, so first thing I'm going to start with is, what's the first step? Last two examples. Equation. We're going to write the formula. Okay. Awesome. We're going to start with the formula. M equals the limit as h goes to 0 of f of x plus h minus f of x all over h. What the hell? Okay, I have the formula. Now, what I'm going to do, what we've been doing so far is substituting in our x value. But we don't like have a specific x value. So what we're going to do instead is just go on to the next step. We don't have an x value, so I'll just leave it this way. And now I'm going to plug this into the function. Yes, it is, which is why I said, please write small. Substitute into the function. Into y equals x squared minus 4x. So limit as h goes to 0 of, okay, so first, everywhere where you see an x, you're going to plug in x plus h. So I will have x plus h squared minus 4 times x plus h, all plus 2. Minus, and then guess what? The second part, you're literally just writing the function. If you plug in x, it's going to be your exact function. Okay, cool. X squared minus 4x plus 2 all over h. Not the worst you've seen. It's just, you know, a little cray-cray. Did I not write this correctly? Negative 4x? Yeah.
Oh, I see.
Yeah, so everywhere you see an x, you're going to be plugging in x plus h on the left side. Okay, so now is the fun part of Algebra 2 where we FOIL and combine and something simplify like terms. You're disgusting. Okay. No, I'm sorry. That was recorded. That's horrid. Okay. X squared plus 2xh plus h squared plus 4h minus 4x is 2. And don't forget to distribute the negative. Okay. Distribute the negative. Minus x squared plus 4x minus 2. Okay, and now see if anything goes away. Like for instance,
Yeah.
the 4x.
Squareds go away.
Those guys go away.
And the 4x's go away.
The 2 go away. X squared goes away. Not bad at all. Let's see. Limit as h goes to 0 of 2xh plus h squared minus 4h all over h. Do you have an idea next thing we're going to do?
Fact.
Just pull down h because it's in every single term on the top. And once I did that, I can cancel the top and bottom. We're so close. We're so close.
Bye-bye.
Oh, shoot. Oh, that should be minus. Drag substitution right here. Is this an equation? That's what we were supposed to find. It was an equation of the slope. So I could pick any x value. I know what the slope of the tangent line will be. At 0, the slope's going to be -4. At 2, the slope's going to be 0. I know the slope at any x value. And that's significantly more useful than just knowing at one point.
Bless you.
So, also, if you're done, just go and like pat the person next to you on the back. Like, tell them good job. You just did some calc. Just did some calculus. That's right. Build each other up. I'm sorry, Maya.
That's what we have to do next year.
Pat, pat, pat. Some, a little bit. It has to be harder, but more intense.
I'm still confused as to. I understand all of it except at the very beginning when you're substituting in the function into the formula. Like.
So.
You know what I mean? Like I don't know.
So we don't have a value for x to plug in.
Yeah.
So I can't just be like, oh, f of 2 plus h.
Yeah.
So I don't have a value to actually plug in for x. So instead of plugging in like, oh, f of 2 plus x, f of 2 plus h into everywhere where you're in the x, instead I plug in a x plus h.
Okay.
Yeah, so this is nice because it makes it more general. Because imagine if I gave you like, find the tangent value at these 5x values. The way we did it before, you'd have to go through every single one. But here, once you find the equation, cool, just plug in and you'll have your values.
Okay.
Okay, let's go on to the next one.
When the teacher baby starts.
Mrs. Co. She's awesome.
Who teaches calc?
Yo no sé mañana.
Are you?
I don't know.
Possible.
I don't know.
It's a possibility.
Swallow my heart. I'm dead inside. It just does nothing.
So when are you gonna know?
Cold heart. What?
When do you guys know?
As soon as by the end of May. Probably beginning of June at least. Because we're still trying to figure out sections, and that's why I'm like, well, like, because it totally depends, right? This year there's 2 intermediate algebra classes. I don't know if there'll be 1 or 2, right? So like the number of sections each, and so the division up, it's different.
I feel like,
Yeah.
wait, I heard a rumor that Miss Casey isn't teaching AP calc.
False. I don't know who said that. She teaches it every year, so. Let's keep going. First step, formula. Formula. I have 1 minute left of my screencast. Woo, okay. So everywhere where you see, okay, so I don't have a value for x to plug in, so I'm going to skip ahead to the step where I'm substituting wherever you see an x. First I'll put in x plus h. So this is going to be 2 over x plus h minus, let's see, if I plugged in x into the function, it's literally just 2 over x, all over h. So this one, it's not like the calculus concept is hard. It's literally the freaking algebra. How do you simplify this? Like on top, oh my god, I have 2 over x plus h minus, like, I gotta fix that top first. Gotta fix that top first. I need to have it have the same least common denominator.
Plus h. Oh.
Least common denominator. Okay.
Now it's
And now it's over. It's done. I ran out.